In this video, I want to continue to explore our trigonometric functions, the cosine of x and the sine of x, to see what relationships we can garner between these values. And again, let's remember that when we say the cosine of x, we're really talking about some kind of an x position here. Some kind of an x position where the cosine of the angle here, making the yellow line, times 5, because again radius of 5 is this value here, 5 times the cosine of let's call this angle here 45 degrees. Sure, this x position is 5 times the cosine of 45 degrees, and this y position is 5 times the sine of 45 degrees. And in this video, we're going to see what we can figure out about the sine and cosine just from this definition. And the first thing I think would be good to do is to just draw out the triangle here, because now hopefully we have a solid understanding of what it means for the sine and the cosine to be functions of the circle. I think it's safe to start thinking about triangles now. If we were to draw out a triangle, and we make sure that we're giving ourselves a right triangle to begin with here. Typically with the sine and the cosine, we think of having a radius of 1. And if you wanted to deal with a radius of 2, for example, you would take 2 times the cosine of your angle and 2 times the sine of your angle, just as we're taking 5 times the cosine and sine of our angle for our circle of radius 5 here. And let's say we have some angle here, of x. Well, as we hopefully know by now, on these videos, we have in the x position we have the cosine of x, and in the y position we have the sine of x. And the first fact that I want us to look at is if we just remember the Pythagorean theorem of triangles. The Pythagorean theorem here up here states that a squared plus b squared equals c squared for some right triangle in which a and b are its legs or its small sides, and c is the hypotenuse. And there are many proofs of this fact. It's very useful because here we have a right triangle, and what we can say is a is the cosine, b is the sine, and c is 1. And if we were to just apply the Pythagorean theorem, we would find that the cosine squared of x, this cosine 2 of x, is meant to be the cosine of x squared, plus the sine squared of x. This will always equal 1, regardless of the x position. The sine squared of x plus the cosine squared of x will always equal 1. This is a very handy fact called this is called the Pythagorean identity. I wonder why I got that name. This is called the Pythagorean identity, and this just falls straight out of the Pythagorean theorem if you set up your triangle. One fact that is perhaps a little bit less obvious, but that is still very useful, is if we notice here this angle. Well, we know all the angles add up to 90 degrees, so x plus, and then this 90-degree angle, plus we don't know what this angle is yet, plus y equals 180 degrees. Well, we subtract 90 from both sides, and we're left with 90 degrees. So we get that x plus y equals 90 degrees. And another way to write this would be that y equals 90 degrees minus x. So here, instead of writing y, I'm going to write 90 degrees minus x. And if we consider this here, another way that we could have drawn this triangle is with the 90 degrees on the other side. So if you imagine kind of flipping the triangle over like this onto its back side, what would we get? Well, we would get a triangle that looks a little something like this. Let me try to draw this more straight. A triangle that looks a little something like this. And this here, this is now 90 degrees minus x. This here is x, and our angle is still 90 degrees. And now this side here is still 1, but now we've flipped ourselves around. This is the sine of x, and this is the cosine of x. And well, what can we notice? Well, this right triangle looks very similar to this right triangle, except the values are switched up. And if we think about this for a little bit, we can say, hey, maybe we can generalize this, right? Because this looks like, if we don't write down the cosine of x, and I have been writing this incorrectly here. This here should be the cosine of x, and this here should be the sine of x, because this is our flipped triangle. If we had just neglected to write down the cosine of x and the sine of x, and we had just written, 90 degrees minus x and x, if we had just written this, I probably could have convinced you that just as the cosine of our degree angle x here in this triangle, the cosine of x is the lower side, that the cosine of, well, x could be just 90 minus x, of 90 degrees minus x, and that this is the sine of 90 degrees minus x. Right, just flipping the triangle around, we get a new angle that looks like our bottom right angle, as if now we are kind of on our triangle. If we had before had, if I erase this here, oops, didn't make a new layer, it seems. If we had before had some sort of, just pay attention to the new lines, if we before had some kind of an angle like this triangle, if this was what we had before, and now we were trying to find 90 degrees minus x, you would agree that 90 minus x has its own cosine and its own sine, just like x had its own cosine and its own sine. So if we come back down to our triangle here, we can say, well, hey, in this triangle, we see that the sine of x, is, well, it seems like after flipping, this sine of x side is the same as what we are now saying is the cosine of 90 minus x. And this cosine side, after flipping the triangle, is looking pretty similar to what we're now saying is the sine of 90 minus x. And if we just come up here, what we've indeed found is just a new way to express these functions. The sine of x is equivalent to the cosine of 90 degrees minus x, and the cosine of x is equivalent to the sine of 90 degrees minus x. And just to make this a tad concrete, if we come back and remember that the sine of 90 degrees, the sine of 90 degrees equals 1, because we're putting our entire radius, we're putting the entire radius into the y position here. Well, according to our new identity here, the sine here, the sine of 90 degrees should be equivalent to the cosine of 90 degrees minus our angle, which was 90 degrees. And well, what is the cosine of, well, 90 minus 90 is 0 degrees. The cosine of 0 degrees is the same as putting all of our effort into going to the the x-axis, and this, the x position, will also be 1. And ignore that this picture has a circle of radius 5. We're thinking of just having the unit circle here with a radius of 1 in this case. This is how you typically think of the sine and the cosine. But down here, the cosine of 0 is equivalently equal to 1. So here we have the Pythagorean identity on top, and here we have a new set of identities that we just discovered here. And these two sets of identities are very important to trigonometry, and hopefully you can see how the Pythagorean identity just falls out of the Pythagorean theorem, and how these new identities that we've found, that these new identities fall out of this flipping motion of the triangle if we flipped the degrees and found new names for the sine function and the cosine function.